Hi, my name is Jason with Mount Baker Mining and Metals, and today we're going to run 3 different samples that a customer sent to us. And these look like they're all samples from electronics recycling. This is the first sample we're going to run. It has a lot of, the customer said, ferrite dust and rare earth metals in it. But you can also see there's some little copper wires and some other materials that we're going to try and separate by density. This is the second sample. These two are, I think, together. This is just a coarser fraction, and it looks like either ground up circuit boards or some sort of electronics recycling. The customer was a little closed-lipped about exactly where these came from. And then this is the third bag, I think, which is the same as this, just a finer screen fraction. But there's a lot of copper wire in it, some plastic, and I don't know if he's capturing aluminum or what out of this, but we're going to run it on our 4-foot by 8-foot shaker table and see what metals we can separate from the plastics and the other waste. So we've wetted the material down a little bit so it's not so hydrophobic. But if you take dry material, especially electronics waste, and try and run on the table, it oftentimes will float. And when we run new samples like this, I like to run slowly to start out with, because I'm not quite sure how the material is going to react on the table. Okay, so we've run our shaker table a little bit here, and you can see the big band of black ferrite that's actually dense enough that it's working its way up onto the cleaning plane and down into the number 1 concentrate port. But you can see this finer gray stuff here, which is probably lead or tin, working its way up onto the cleaning plane, coming down into a nice band right into the number 1 cons. And down below the ferrite, this is probably aluminum or your lighter base metals. And the copper wire, surprisingly enough, it has enough surface area that it won't settle down into the grooves in the ferrite. So a lot of your fine copper wire is coming down into your number 3 middlings, and your finer copper and some of your pins are coming down into the number 1 and number 2 mix. So we're actually getting pretty good separation on the table. One of the advantages of the ferrite is it is magnetic, so without too much work you could pull it out with a magnet fairly easily. So I'm not too worried about separating the ferrite from the rest of the material, but you're getting really good separation of the dense, heavy base metals, either lead or tin, and the aluminum is separating very nicely. So we'll keep running the sample. I'm looking here for any precious metals. I don't see any yet. But we'll run a little bit more, we'll stop the table, and we'll take a look at some of the separation we're getting. Okay, we're almost done with our bucket, and we've stopped the table now so we can see if there's any precious metals at the leading edge here. And I don't see any precious metals, but you can see the clear band of gray that's coming down into the high grade. And you're starting to get I don't know if these are like electronic pins or what, but they're coming into the high grade as well. Again, the ferrite is coming into the number 1 as well, but I think we're going to rerun the number 1 back on the table and see if we can clean this up a little bit and isolate this light gray dense material from the ferrite. So we'll finish our bucket here, and we'll take a look at the number 1 and maybe rerun it back on. Here's the number 1 port from running our first sample, and we're going to try and rerun it on the table and clean up some of that gray dense material from the ferrite. We've got a lot of ferrite in that first run, so I'm going to run a little bit slower on the table and see if we can clean up some of that gray material a little bit better. So this is our second sample, and we've mixed the two together. There's a larger fraction and a smaller fraction. And this one has some plastics in it that are actually light enough to float. So I'm just decanting the water off the sample after we got it wet. A lot of the plastics are so light they float, and we'll run this sample and see what we get. All right, we're about a third of the way done with our second sample, and this looks a lot more like what we're used to seeing when we grind up boards. A lot of plastic waste going down into the tailings, and then the heavier metals, the copper and probably lead and tin solder going off into the high grade. The table's doing a really good job of separating the light plastic and the waste flowing down into the tailings from the heavier metals that are working their way over to the high grade quartz. Because there's so much waste in this, I can feed it a lot faster. So this is our second sample. We're just about finished running, and I don't know if you can see it in the camera, but right along the leading edge, there's little tiny pieces of gold all the way down here going into the number 1 port. And that gray silver band is probably another lead or tin solder. Maybe it's a silver solder, I'm not sure. But the gold is right at the leading edge of that because it's the most dense, and it's working its way right down into the number 1 port. So it'll be interesting to see what the assays are from these samples and see if we're recovering most of the gold in our number 1 port. So we've started to brush down the table, and usually when you brush down the table you get your best showing of gold, and you can see right along the leading edge of this gray stuff there's gold pieces coming all the way down there. So there is some gold in this stuff.